Canvas training. Learn and grow.
Today's session is about the virtual network in Azure. So how you create it, what are the basic terms that we need to understand first we start creating or working with the networking part of the Azure. So today's session will be about it, networks and network security, the basic overviews of both the services. Okay, so what basically a network is, it's a logical boundary in which two or more computers communicate with each other through various network protocols, and the basic example would be a LAN and WAN. So when we say virtual network, it means we are creating a network in remote location, or we say in the cloud. So anything we create in the cloud would comes with the term virtual, because we are not hosting or creating that service in our infrastructure. We are creating it in the remote place, or the cloud service providers infrastructure that we are using as a cloud service model. Correct? And that is only a virtual network. Virtual network will be the basic boundary of your infrastructure that you're creating in the Azure cloud. For example, the applications that we'll be hosting will be hosted in IaaS or a PaaS service. IaaS means a virtual machine, a PaaS services, maybe a web services or function or a logic app. So basically in the back end, that resources will be connected to the virtual network so that they will be able to securely connect with each other in Azure. And that basically is an Azure virtual network. I will go ahead and create the virtual network. We'll get to know more about it. So today's agenda will be understanding what is Azure Virtual Network. We'll create one. We'll understand the IP address systems, that what is static dynamic and what is public private IPs in Azure. We'll understand how we create address space or define address space in virtual network, how we'll be using subnetting under that address space to divide the small logical groups under that virtual network. We'll understand and explore what is Azure DNS and what is custom DNS. There is a type of a DNS that Azure provided there as a PaaS service in the backend that Azure only manages, and we just have to use it. That is Azure DNS. And if we want to create a custom DNS server, we can create it in the form of virtual machine, and we'll define it in the virtual network. Okay, and DNS, basically DNS, it's a domain mapping system or a domain naming service. Computers on the network communicates logically, not alphabetically. For example, they will communicate with the IP address. In the backend, the data will be in the form of ones and zeros. But as a human being, we use a naming system. Right, it's easy for us. So what DNS servers do is they maps the IP with a name and name with IP. If you request that you connect or you want to connect to a server called abc.local, the request will go to DNS. It will resolve to an IP that the IP of that abc.local system is this, and then we will be able to connect directly to the IP. Correct. And the next one will be network security group. Network security group is nothing but a basic firewall down Azure that where we can mention rules so that the internal and the outbound traffic can be controlled. Correct? We'll go deeper there and we'll get to know more about that. Okay. There's a basic definition that I've mentioned here. This Azure Virtual Network is a fundamental building block for your private network in Azure. So when you create an Azure Virtual Network, we can say it's a private network that is used only for our infrastructure. Correct? There is no public internet, or there's no direct connectivity of the public internet until and unless you have a public IP assigned internally to that resource. Correct? So VNet enables many types of Azure resources such as virtual machine to securely communicate with each other through the internet and the on-premise. So that's a hybrid situation. In many times at an organizational level, you will be having virtual networks in Azure where you have your applications running in the cloud, but still you will be having your office location from where you will be managing those applications. So there will be a hybrid connectivity, a gateway connectivity that we will see in the pairing or the gateway session of the lecture, where we connect your Azure cloud network with the on-premise network, so that we'll be able to achieve high bandwidth and low latency connections. Correct? That will be calling as on-premise. So you can connect virtual network on the Azure and your on-premise network through gateway, and you'll be able to communicate through the backbone of the network. Correct? There are certain terms we need to understand. That is, first, address space. Address space, as I mentioned, that virtual network is a logical boundary. The address space defines how big your boundary is, and it's a format of CIDR. CIDR format in networking that we use 192.168.0.0/ if anybody worked on the Windows Server level, when we create the DNS server, correct, we define a scope that how big our network is. Correct? For example, everybody might be familiar with this terms of 192.168.0.0/24. So how IPv4 addressing works is each of this is 8-bit. Correct? It denotes the 8-bit. So this is total of a 32-bit IPv4 address. Correct? and I've mentioned /24. After the term slash mentions 24, which means first 24 bits will be fixed. 888, correct? First 24 bit will be fixed, and the last bit will define our boundary. And how we came to the number 256 is basically 2 raised to 8, that is 256, correct? Why 2? Because in the binary format there are only two logics, 0 or 1. With 2 digits we define the whole address space. So 192.168.0.0 is the first IP of our address space, and 192.168.0.255. So 0 to 255, it will be 256 addresses. So this is our boundary. We have 256 address that we can use to assign to the resources under your virtual network. As I've taken a small example, with 256 address you can create 16. First 16 bit will be fixed, the next 16 bit will be variable. So 2 raised to 16, it will be 65536, correct? So the start will be 0 or 0.02 1. Yeah, the end address of 256. This is how we define the boundaries or the addresses in the address space. When we create a network, you can just give the address space and it will calculate the address, subnet mask, and everything. And that was the address space. Subnets, when we create a virtual network or we define the boundary, we divide that whole boundary into the small sub-logical networks so that we can isolate our environment, right? For example, if I have used 24, this is our whole boundary. I need to divide into 2. So what will be the division? For example, I will divide one network into 192.168.0.0 to 192.168.0.127, correct? And 192.168.0.0 to 192.168.128.0.55. So this whole boundary 192.168.0.0 to 192.168.0.255 divided into 2. So we you can consider in the CEDAR format like 192.168.0.0 slash 28. Where first 28 bit will be fixed here, 192.168.128 slash 28. Correct? We have divided the whole address space into two subnetworks. And while creating the virtual network, yeah, we will be giving the address space like this in the subnetwork, so that it, in the backend it will get this much of IP address for our subnet and be using accordingly. I will show you one more example in the next slide with the help of a tool. Correct? Next, regions. So VNet, whenever you create VNet in an Azure environment, that VNet is binded with a region. For example, you can create a virtual network that will be in east to west, west to west. In any region, it will be binded in the backend to a region. And you can create multiple networks in multiple regions. And you can also create a connection between those virtual network as well. We use a term peering that we'll see in the hybrid connection session. What is peering? Peering is basically connecting two virtual networks in the cloud with each other. So basically, when we say connecting two networks in the legacy infrastructure, we used to have a gateway. So gateway, what does a gateway do? It connects to two different networks so that the resources in those two networks can communicate with each other. In peering, we don't have to create a gateway. Azure manages the peering gateway in the backend. We don't see it in the portal. We just create connection and we'll be able to communicate with the resources in both the networks. Also, VNet is scoped to a subscription. You can implement multiple network in multiple Azure subscription and region, and you can also connect to a virtual network from a different subscription as well. Okay, we'll just go ahead and create what virtual. There's the steps mentioned, and the same steps I will be following. So please go through it carefully. So I have a resource group created already. So this is my subscription in Azure. I've clicked on Azure class. It's my class 3. It's today's class, and I create a virtual network add. You can search for a virtual network directly from the search bar, or you can navigate to the marketplace section, go to networking, and create a virtual network from here. So subscription, yes, selected the existing subscription. Resource group, name of the virtual network, I would like to give it VNetDevQS. So try to give a name of the virtual network according to the application or the environment you are using. It will be easier to understand. So this virtual network, for example, I'm using for development environment in our infrastructure, and I've used US, so that by seeing the name, I can get that I have created this virtual network in East US region, or you can say EUS, right? Region I've selected East US. Next, IP addresses. So by default, there is one IP address already mentioned here. So I will use my IP address. For example, I use 192.168.0.0/24. So it's the address space that will give me 256 addresses. I've used it. You can also use IPv6 address, but no one has used IPv6 as of now. IPv4 is enough. We'll get many IP address to manage our whole infrastructure. Once we have created a boundary of your virtual network, now we can also add subnets. Like we want to divide those logical boundaries into a small network. So I can click on add subnet. For example, I have a two-tier application. For example, my application have some front-end servers that will be web servers, and back-end servers that will be a database servers. So I will create two subnets. I can say front end. From this chunk of IP address, I will need, for example, half IP address. I've divided that IP address into two subnetworks. So that will be 25, I guess. Okay. Here, 28 will be 11 address. It will be 25. Okay. You'll see one thing here. As soon as you enter the address space of the subnetwork, it will automatically show what is the first and the last IP address. It will be 192.168.0.0 to 192.168.0.127. And you see one more thing here. You will get from this 128 IP addresses, you will get 123, and the remaining 5 Azure will reserve that IP address. So why Azure reserves is for its backend operation. For example, in future, if you create a gateway into that virtual network, then it will be used for rerouting. So Azure use that IP addresses for the backend purpose, so that we'll be able to connect the subnets with the resources in the subnet should be able to point to the resources in the different subnets. So in the backend, 5 IPs get reserved in the Azure side, correct? Service endpoint is something that I will explain in detail in the lectures when see the hybrid connections, but I will just give you a basic overview. Service endpoint is, for example, let me create the subnet. I will show you when I create the second subnet. Okay, I am not selecting any service endpoint here. I'm just creating one subnet called as front end. Okay, now I will add one more subnet called as backend, and then I will use the remaining address space for correct. The starting IP address will be 128 to 255. So I've created two addresses. Front end, for example, for front end, I will be using web servers. For example, I've hosted a website on IIS and I'm using a virtual machines here. So the public facing servers will be the front end servers. In the back end, I will be having my database server. That application will be using that database server. Now, from front end to back end, for example, if I want to connect from front end to back end, I want my service to be using the private or the backbone of infrastructure of the Microsoft Azure. So I can use any of the service here. For example, in the backend server, I've deployed a SQL server. So when I click this option, SQL server here, in the backend, I've deployed a database server and I select the endpoint Microsoft.SQL. So any communication coming to this subnet on SQL service can only be used or can only be routed through internal networks. You cannot publicly connect to the SQL service into the subnet. So to restrict the public access and to use the Azure backbone network, the service endpoint use. We'll get to know more in the section and we'll discuss more about it. We'll be using it. So that's the basic of this, correct? And I save, you can save here. Now most of the things are ready. So yeah, next security. There is option called as Bastion host. What Azure Bastion is, it's a PaaS service, it's a managed service. The server or the resources will be created and managed by Microsoft in the backend. You don't have to create a jump server. That will be a jump server, but it will be in the backend. Microsoft will manage it. You can directly take RDP from this browser. When you enable this option, configure the Azure Bastion host. Directly, you can click on the virtual machine you created, click on connect option, click on Bastion. In this browser console, you will be seeing your Windows server. Okay, so for explaining this Bastion option, I have to first explain the legacy, that how we used to connect to the VMs in the remote servers, and then Microsoft came with an option called as Bastion host. Microsoft says, I will manage the backend jump server and everything. You just enable this option and configure it. And from the browser only, you can take the RDP of the VMs, correct? The DDoS protection is, yeah, it's the feature of the virtual network where you can enable and get an alerts if there is any attack happens, or any alert that you get will be configured from here. So firewall, I believe you worked with any firewall technology. So basically this is the PaaS offering of Azure, that your firewall will be connected and created in the Microsoft infrastructure. You will only have a console here and you can manage the firewall rules from the Azure portal. Okay. For now, we'll be keep this option disabled. Next are tags. Everyone knows that you can assign a labels to the resources that you create in Azure so that you can easily identify the resource, correct? Option create. It will validate that all the options filled are valid and there is no error. And I will create it. My virtual network has been created. I can directly click here to go to the virtual network that I've created, correct? There you can see all the options. First, on the Essentials tab, you can see under which resource, which location, which subscription this virtual network is deployed, what's the subscription ID. You can add a tags here. Address space, I've defined 192.168.0/24. Just hold with this option for now, DNS server. In next couple of slides, you will get to know better what is this. Azure provides DNS service, correct? Here, if I want to change the address space, if I want to add another address range, such as 10.0.0.0/24, I can add it. I can save here, I can add it, and I can manage it from this virtual network only, correct? I can also change the network address that I first created. For example, 24 has 256 addresses. I want more, so I can change it to 22, or I can change it to 16 so that I get more addresses in my virtual network. But just remember, whenever you do any changes in the networking part of the Azure, just be very sure what you're changing, because as we know, changing a small thing in the network can have a very big impact on your applications. For example, you saw that I've changed the address space. So whenever you do that, basically we should not do, we should, whenever we create in virtual network, we should always create a boundary that is sufficient for our application, and we will not make any changes to the address space. But in case, for example, from the development, you need to test what will happen. So if you have virtual machines already created in the subnets, and then you want to change this address space, for example, if you want to decrease the address space or increase the address space, you might have to move the VMs from the subnet, or might have to recreate it. So whenever you do this thing, just be very sure what you're doing in the networking part, correct? Basically use the address space ends with /16. If you have only one or two virtual, you have decided you will be only deploying one or two virtual network in your environment, one will be for dev and one will be for production. So design according to the requirement and select the address space accordingly. 16 being the address space that will give you more than 65,000 IP address, that will be more than enough, right? So this is where we see address spaces. This option where you will see how many subnets we have created and how many available IPs are there. For example, I have created one VM under this subnet. Okay, so it will then show 122 because one IP is assigned to that VM now, the network card of that VM. Right. So as you create resources in the subnet that uses the IP address, this number will start decreasing. I have not yet created any resource. That's why these all are blank, and I have not created the security group yet. We create in the last section of this session. There's a DDoS protection and firewall option that we have kept disabled for now. Correct. So these are the basic options. These are the advanced options that we'll be taking in the next couple of sessions in the networking part. The next slide is static and dynamic address. It's pretty understandable from the name itself that dynamic means changing, static means stationary. For example, I create a VM in virtual network under a subnet. Say I've created a front-end server and created it in a front-end subnet. Correct. So there are 128 addresses available, from which 123 are readily available to me. 5 are reserved. So which 5 will be reserved? The starting 4 and the last one. So in this case, 192.168.0.0, 0.1, 0.2, 0.3 and 0.127 will be reserved in Azure. Between that address space, it will be able to use it with your virtual network or network cards and any resource that requires a network card or IP from the subnet. So when I create first VM in this subnet, the IP, automatically Azure assigns the IP, internal IP as 192.168.0.4 because 0 to 3 and the last IP is reserved. So first IP that you will be get from the subnet will be 0.4, correct? And if I keep that IP configuration as static, so that 4 IP will be always attached to that NIC card. Okay, let me show you by an example. Let us try to create a network card, not the VM. I'm creating a network card. It's basically a network card that will be used by VM to communicate through the network resources. You'll see it will ask for their virtual network. It's ask for the subnet. I can use backend, and here you will see two options, dynamic or static private IP address assignment. So if I select dynamic, and when I create the network interface, it will select any available IP address from the subnet. So anybody heard a term called DHCP pool? So the pool has multiple available IP addresses. So whenever some resource or say some service asks for an IP to the DHCP pool, the DHCP pool what will do? It will take an available IP from the pool and give to that service. And once the job of that service is over, that IP will be free and come back to the pool, and it will be assigned in the next instance to any other service. So it's dynamic, that it will give until the requirement, and once the requirement is fulfilled, it will come back to the pool and it will be assigned to any other service again it asked for. That's the dynamic operation of the IPs, but it is not recommended in the production environments because we don't want our IPs to be changed, because in the backend when we configure the application, we'll be binding that IPs of the particular VM to different services, and if that IP gets changed, we will face a lot of errors. So the best practice is keep the assignment static. As soon as I click static, one more option pops up, that what is the IP address that you want to be static or to attach to this network interface. I want 192.168.0.10. I want this. So this will be the IP address that will be always attached to this network interface, and it will be static, correct? So the different between two options. Dynamic, it will give any IP to that network interface. For example, consider this network interface will be attached to a virtual machine. Whenever we create virtual machine and a network interface get automatically created, I'm just for the sake of example, I'm creating it separately. So I've created a VM. I use the dynamic IP assignment, and Azure assigns 192.168.0.4, correct? And whenever I turn off the VM, that IP get released and it will be again back to the Azure pool. So whenever I restart that VM, there's a high possibility that the different IP will get assigned to my VM, correct? So these are the two options here. If I click next and create, that interface will be get created and the IP will be the private IP, this IP that I've mentioned here. Okay, the stuff I've explained here is just mentioned here theoretically, that when if you delete the VM or if you move VM to a different virtual network or you stop the VM, that dynamic IP get released to and get back to the Azure pool, and then whenever you try to restart or recreate another VM, that IP will get assigned to that resource. In static, you mentions the IP that I want this particular IP address to be attached to the network card, and it will be attached to it until and unless you go and change it, correct? Public and private IP address. So as I have given you the example for jump or a stepstone server, for example, you have one public application that is hosted on the front end part of your virtual network. You want that application to be accessed publicly, so you will need a public IP. Public IP is nothing but a channel to which your infrastructure, your application will connect it to the public internet, correct? For example, you have a VM, you have hosted an IIS site, and you have attached a public IP. So that public IP will be an inbound channel to that virtual machine, so that the external network will be able to say, reach that to VM in your Azure network and access the application. Okay, public IP can be used with virtual machine network interfaces, load balancers, and application gateway. These are the load balancing service of Azure. We'll see in future sessions. Subnets have already explained a small logical boundary. Correct? So private VMs, as we have mentioned in our address space. Okay. these all IPs is private. For example, if you've created virtual machines here, the private IP that assigns to that virtual machine, get assigned to the virtual machine is .4. So you cannot connect to that IP publicly from your public internet because it's an internal IP. If I add a public IP to the virtual machine to a network interface, and if I ping to that public IP, I will get response because that public from the Microsoft backend, that IP is exposed to the internet. Correct? So these are the two IPs that we'll be mostly working with, public and private, and we'll be using with multiple Azure load balancing service. Okay, just consider that you have one virtual network. Whenever you read any documentation about Azure, you will be getting more such of these diagrams. So just try to be used to it because there are certain formats and icons that Microsoft uses. It becomes very easier to understand. For example, this icon is for virtual network. So consider this outer boundary as your Azure virtual networks. Outside that is the public internet, correct? And as we created a virtual network in this example, there is one front-end subnet, there is one back-end subnet. I have front-end web applications hosted on these VMs, and I have database servers hosted or created in back-end subnet. This is not exposed to public internet because it's a back-end service. There's no need to export it because it will be used by internally by the application servers. But my application servers has the front-end application that needs to be exposed to the public internet. So consider this icon for now as a public IP and consider this as a private IP, correct? So people accessing the application from the public internet will have an inbound channel through public IP so that they will be able to connect to the application server, and the application server will be connecting to the database server internally with the private IP. There is no connection from private IP directly to the internet. No, the internet have a public IP as a channel to communicate to the front-end application server so that the web page will be served from here to the public internet user. But internally, those application server will be using these database servers to private IP. So that's a two-tier example. This is the icon of network security group, which will be our next topic. I will explain you there. Consider the virtual network here. Virtual network itself don't have any charges associated with it. Okay. Virtual network is built upon the traffic flowing between the virtual network. For example, how much data is flowing into the virtual network. So any traffic come from outside network inbound to Microsoft data centers is free of charge. Correct? From outside to inside Azure data center, there is no cost associated with it. But traffic flowing from Microsoft data center to outside network is chargeable. First 5 GB is free, and next per GB there is some cents of cost that you can go to the pricing calculator and pricing page of Azure and let you know pricing. Okay, this is the tool where you can estimate the cost of what we'll be using. For example, here, so virtual network have the cost associated with the data transfer. Okay, you can see outbound data transfer, inbound data transfer. It works like that. So you can go through this pricing calculator and explore the options here. Okay. Now coming to DNS. DNS basically, as I said, is a system where it maps a name to a public IP and public IP to name. For example, there is a VM called as DB, and fully qualified domain name or full domain name of that VM will be db.contoso.local. For example, here consider this as a DB VM and this as an application VM, front end, back end, and front end VM wants to connect to the backend VM, correct? You know the VM, the name of the backend VM. You, for example, you're trying to take an RDP. So we'll type a name that I want to connect to db.contoso.local. So there will be a DNS service. I will explain you in the portal as well. That the request will be first go to the domain name service, and the IP of that particular VM that is mapped to this name will be given to that VM, and that VM will connect to that VM through that internal IP. So this is how domain naming service works. When we created the virtual network, you saw the option here is Azure provided DNS service. For example, you have a test environment or very small environment. Basically at the organizational level, we deploy our domain server, a domain controller, and we install a role of DNS on that, correct? And we basically use our domain name server or domain controller for resolving the names in IPs. We'll have certain set of DNS too. But if you are just creating the environment for testing or you have a very small environment, you can use Azure provided DNS service. What is this? It DNS default Azure provided. So whenever you connect two VMs in the same virtual network, a default Azure provided DNS will come into the picture that will resolve name and IP to name. For example, I have VM1, VM2. I want to create a connection, how to connect VM2 from VM1. So I will just type the name of the IP. Not necessary, it should be a fully qualified domain name because we have not created a domain only yet. Correct? We have just two VMs here, standalone VMs, not connected to domain, nothing, just a standalone VM. And I have to connect it. These VMs are not connected to any domain. So no picture of domain controller or DNS server comes into the picture. So in the backbone of Azure, there is one DNS service that resolves name to IP. And this is by default, that is mentioned here. If we do not want to use this option, we have our domain controller and DNS server that resolves name to IPs and IP to name. And we have certain DNS rules there that will be used by our environment. So what we will do basically, we will click on custom here and I will put the IP of the DNS server. For example, I have two domain controllers in my environment that I've created on Azure only. And the IPs of that two domain controllers are 192.168.0.4 and 0.5. Okay. So what we'll do in the next time, when you click here on save, first of all, you see the caution mark here that virtual machines within this virtual network must be restarted to utilize the updated DNS server setting. So it's a best practice that once you create the virtual network and deploy your domain controllers in the virtual network, the first thing you should do it, come here, enter the IP address of the DNS servers, so that going forward, when you create your infrastructure, they will be directly using your DNS servers. There is no need to restart it. Or otherwise, if you are changing the domain controller IP address, it's not best practice. But if you are adding another domain controller, so you have to add the address of that domain controller here and restart all the IPs present in the virtual machine so that the changes can get reflected. Correct? When you save here, it will save the IP. So next time, this is the same diagram, but consider this as your domain controller. The next time VM request to connect to this VM, it will pass the request to your domain controller, which have the DNS role installed or the DNS server per se. And then that DNS server will reply to that request that this is the IP of the VM that you want to connect, and then it will connect to that VM. In most scenarios, when we will be using a production environment or any environment, any big environment, you will see the custom settings. It is not recommended because it is for only small testing environment or the POCs environment, something like that. Okay, so those are the two options, custom DNS and Azure provided DNS. Azure provided DNS is not recommended because it's for just a testing purpose or a small environment. If you don't have domain controller in your environment, just want to deploy a standalone servers and do some testing, yes, we can do that. But in the production and the big environments, it's always recommended that you use your own DNS server in on-premise or on your virtual network, Azure Virtual Network. Right? You can define the DNS servers in two places. First, you can directly mention here that those are your two DNS servers at the virtual network level. And if you want any particular VM in your environment to get connected to another domain naming server, so in the network card, when we create a network card, let's quickly create one. So there are two places. First, directly in the virtual network, and another one will be on the network card itself. You can just mention the IP address of your DNS server that you want that particular network cards to get connected to, and then it will use your DNS servers that mentioned in the network card and not on the virtual network itself. Okay, you will see the network cards when we see the virtual machine sessions. So that's the private IP address automatically. Since I kept the private IP address assignment as dynamic, the first IP that was available in the subnet was assigned here, 04. Okay, those are the basic options here. There's the subnet, then the virtual network that this network card is assigned to. In IP configuration, you will see what is the assignment type kept here. So yeah, you can only see private IP address. There is no public IP address attached to this network card here. Okay, you can click on IP config and you can change the assignment to static. For example, I want to keep the IP address as 10, correct? I can go here, change the dynamic assignment to static and mention the IP address here. Or you can also create one public IP address directly from here. There is no existing. You can create one public IP address from here, public IP, okay? If you want to keep that public IP dynamic, you can select this option here, or static. So what is the difference when we create dynamic or a static public IP? So whenever you create a static or a reserved public IP, you will be getting charged for that reservation, correct? And if you are using dynamic, you will be only charged whenever you are using that public IP, correct? That's the two different things here. So if you reserve that public IP particular for you, it's like you are purchasing a IP from your ISP. It's like purchasing an IP from Microsoft Azure so that you will be using in your environment, you are reserving that public IP, correct? You will be charged accordingly, charged for the whole time you have reserved the IP. Instead, if you are using dynamic IP, you will be only charged when you are using your IP. And once you turn off the VM, that public IP will go away to Microsoft Azure pool. And the next time you turn on the VM, you will get a different public IP, correct? Is the DNS server. Okay, there's two options here: inherit from virtual network. We have went to the virtual network DNS servers option, and we have declared two DNS servers, 4 and 5. But I don't want that DNS servers to be used by this virtual machine or network card. I want some another one. Okay, I want to use so 20. I have a DNS server, separate DNS server that will be used by this virtual machine. So I will mention it here. So once you change this, the VM will get restarted and it will then utilize or have a priority of using these DNS servers over the virtual network server. Okay, come to the last topic of today's session, that is network security group. So network security group is basically a basic firewall, not an application level firewall, but just a basic firewall that we'll be using to controlling the routing of the traffic coming into or going out of virtual network or subnet. Okay, let me first just create one, go to the details. So as far as I know, a network security group is not chargeable. It doesn't incur any cost. Okay. So when you create a network security group, you can directly attach that NSG to a subnet or to a network card. So if it is assigned to a subnet or attached to a subnet, the VMs, all the VMs under that subnet will be the traffic to that all the VMs will be according to the rules mentioned in the network security group that is attached to a subnet level. If you attach a network security group on a network card level, only that VM traffic will be controlled by that NSG, right? So there are two options here. Okay, this is a network security group I've created for the front end. So whenever we create a network security group, there are certain set of rules that comes by default. Before that, we'll need to know what are the rules here. Rules is basically in the common terms are networking rules. That rules, that means it defines what should be allowed and what should be denied, correct? And there are two types of rules that we mention in network security group. That is, one is inbound rule and one is outbound rule. Inbound meaning traffic coming into that particular network card or subnet. Outbound is traffic originating from the local Azure network and going outside of that resource. For example, if I have attached this network security group to a front-end subnet, front-end subnet will have front-end application servers, correct? So we'll define the inbound security rules according to our requirement, correct? For example, here, if you see, there are three rules that is defined by default, and the network security group rules works according to the priority. So the rules having the higher priority will be used. For example, if I have two rules, I create one rule for allowing a traffic from a particular IP address and one rule to denying the traffic to that same particular address. So how will it work? Since we have the same IP address and we have created two rules for allowing as well and denying as well. So the Microsoft network security group will check what is the priority of that rule. If deny rule has the higher priority than the allow rule, then it will deny the traffic. If allow rule has the higher priority than deny rule, it will allow the traffic, correct? By default, all the inbound connection from the VNet is allowed. For example, if you have virtual machines in the same VNet, by default, that is allowed on any port in any protocol. Port meaning, for example, 3389 will be a TCP RDP port, correct? It is allowed within the virtual network, correct? Any port, any protocol is allowed within the virtual network, correct? This option is for Azure Load Balancer. For example, if you're using Load Balancer in any of your application, then the traffic routing from the Load Balancer is also directly allowed within the virtual network. And that's the last priority, that is deny all inbound. So we have to mention all the rules that we'll be having above it. For example, the subnet has my front-end application servers. I have an application for customer-facing website, and customer will use that website from the public internet. So what changes do you feel I should do here? Because the current network group settings, it will not allow any public internet traffic to go through my front-end subnet, front-end VM, even if you have a public IP, because network security group is restricting it. For example, if you see, there are two options. You can attach it to the subnet or network interface. For example, I will attach this network security group to a front-end subnet in my virtual network. I will go here. I will select my virtual network. I will select my front-end subnet and I click OK. So now the traffic on the front end subnet will be managed according to the rules you mentioned here. So this is an inbound security. So for example, I will add a priority. For example, source will be any, that's internet, correct? Okay, from any port the traffic will reach our front end subnet. On destination side, we can use an IP address of the particular virtual machine or the whole subnet. I believe 25, correct? This is the IP address of the whole subnet, correct? You can also mention one VM from that subnet as well. For example, I just want these rules to be attached to the subnet, but in that subnet it will be for only VM that is using this IP address. I can do that. I can fine tune it to that level, or I can directly use the whole subnet, correct? The destination port I want is HTTP, that is 443, okay, TCP, and the action will be allowed this traffic publicly means from any source on any port, that is internet. Destination would be my subnet, front end subnet, okay, and I can give a friendly name, that is allow HTTPS. Okay, I can also give a description here, and this is the main part, priority. You should not use one or two here, because in future if you want to assign a higher priority, for example, it will not take it only, it will take it from 100. You should not use directly 100 here, because in future if you want to create a rule which have a higher priority than this, then you will be in trouble. So try to use a range such as 1000, correct, and add it. Okay, now if you have application servers running in a front-end subnet, and if you try to request that application from the browser, you will be able to connect it and get the response from that. For example, I want to take an RDP, correct? 3389 is the RDP port, front-end subnet 192.168.0.0/25 TCP. I will assign the rule as 110. I will say allow RDP and add. So once this rule is created, we'll see the question mark here because I've opened RDP to the whole internet. This is not a best practice. For example, if you open the RDP anywhere, anyone from the internet will be able to connect to the RDP. Since they do not have the credential, they will not able to log in, but still it is vulnerable to open RDP traffic to the whole internet. So what I can do is, for example, if you have public IP in your network, for example, you are a solution provider, you have your network public IP or routers public IP, just give it here. For example, it will be something like that. For example, you have a public IP of this IP. It's your public IP that your ISP has given to you, and then the traffic originating from this particular IP from the internet will only be able to take the RDP. Okay, so if I see here, okay, now that caution mark has gone because I have defined the source will be from this public IP. So it's much secure way to connect to the RDP here, correct? So yeah, same as inbound, outbound, any outbound traffic originating from virtual network to virtual network is allowed on any port in any protocol. Okay, any traffic originating from your virtual network or anywhere to the internet is also allowed, because even if you don't have public IP assigned to the virtual machine you've created in Azure, you will be able to connect to the internet. Why so? Because in the backend, Microsoft did a netting. I will explain it to you in the virtual machine section, that your private IP is netted, network address translated to a public IP in the backend of the Microsoft, so that you can access internet. You can access the public pages from the internet. So that's how it works. That's why this rule is mentioned here. If you want to deny it, you can just create a higher priority rule that I don't want internet to be accessed from this virtual machine. I will deny that rule, or I will change this rule according to the default rule, not change. I will create a high priority rule to deny the traffic. Okay, and the last rule is deny all outbound, correct? Same as deny all inbound. You'll have to create rules at higher priority than this. Any rules doesn't match, eventually it will end up in the last rule, that is deny. Okay, so as I said, you can assign a network security group to network interface or the whole subnet. Network interface will be for that particular network interface. Subnet, it will be for whole subnet. In that too, you can also define a particular IP. For that, you are using the rules. For example, I've mentioned here destination as my whole subnet. I can change it. I can change it to this VM. Okay, now the HTTPS traffic from internet is only allowed to an internal address of 192.168.0.4, correct? No other VMs in the subnet will have an HTTPS connection inbound. So this is the level of fine tuning you can achieve with network security group. Okay, so inbound traffic, outbound traffic I've already explained. Okay, and we have also created an attached 9SG to a subnet, or you can also attach it from the night network interface. Yeah, this is the network interface we have created. You can see the option here called as network security group. There is none attached here. We'll click edit. We click on network security group. It will detect what network security group is already created in your subscription. You can select it and you can save it. So you can use one network security group with multiple resources, but best practice should be you should create different network security groups according to the application. You should create one for front end and one for back end, and in that too, if you have multiple front end, multiple back end, and have different requirements, then you should create accordingly. It's totally depend upon how you design your network.
Janba's Training. Learn and grow.